All right, we're going to talk a little bit about domain and range of a function, which is something I know that you guys have seen before, but you also get a little freaked out by. So let's try to understand domain and range of a function a little bit better in what we're talking about when we talk about domain and range. We earlier talked about the word implicitly here, and it says the domain of a function can be described explicitly, or it may be described implicitly by an equation used to define the function. So what that means is we could either tell you exactly what the domain is, they could define it for you, or the equation maybe tells it to us by kind of defining it through what type of equation we have. So if you read this paragraph, it says the implied domain is the set of all real numbers for which the equation is defined. Or you can think of the word where it works. Whereas an explicitly, or if we just say what the domain is one that is given along with the function. So for example, here's an example. The function given by f of x equals 1 over x squared minus 4 on this domain between x is greater than or equal to 4 and less than or equal to 5, this has an explicitly defined domain because they tell us what x values we're talking about. Now, let's look at the next slide. On the other hand, you could have a function like, here's the same equation. We're just going to call it g of x now. 1 over x squared minus 4. This has, you see there's no, in the last one they were telling us it was between x is greater than or equal to 4, less than or equal to 5. You don't see that here. That is not present. All we have is an equation. And so what we want to ask is what values of x make this equation not work? So when the bottom here, if I go down, when x equals 2 or negative 2, so I'll draw plus or minus 2 here, the denominator of this fraction, this denominator here, is equal to 0. And one thing we've learned over the past couple of years is that we cannot divide by 0. 1 divided by 0 is undefined. And so this equation, this function works for all of x, every x, such that x does not equal plus or minus 2. Because for x is plus or minus 2, it is undefined. I'll put an END for undefined. All right? Here's another example, finding the domain and range of the function. So the domain, you should be thinking of x values, inputs, things that make the equation work. So as I look at this one, f of x is equal to the square root of x minus 1. One thing we know about square root functions is we cannot, on the real numbers, find the square root of a negative number. So x minus 1 can never give us a negative number. Cannot be less than 0. All right? And so you'll see here they define the domain as x is greater than or equal to 1 because if x is less than 1, we get a negative number underneath here for the function, and then we cannot define the square root. So the domain here is the set of real numbers such that we go from the interval 1, that's the first number it works for, and then comma, all the way to infinity. X can be infinitely big, but it cannot be less than 1. Now to observe the range is equal to the y values, the set of y values that we get, the f of x values that we get out of the function. And so the range, you see that this function is never less than 0 because this never generates a negative number. And so these values, these y values over here, are always positive. And so the range, or our set of y or f of x values is from 0, that's the smallest we can get, and then this also gets infinitely big in the y direction as we go.